As promised in the previous session, this time we want to actually classify matter according to each state. We will do the states in this session, and then following session we'll be doing according to the composition. So what we mean by states of matter, right? We are just referring to the physical form in which we can see matter around us. Okay, so we exploring those physical sections in this thing, but then let's take a look at matter is. We say matter is anything that has mass and occupies space, and we say chemists are interested in understanding the behavior of matter all the time. So if they want to understand the behavior all the time, how do they actually do that? They want to see inside matter what it is composed of, its composition, right? They want to look into it and see what it is. So then the question is, if we try to see deep inside matter, what are we going to get, right? So if you have something and you are looking deep into it, I'm using my hand deep into it, you'll be seeing that you can see inner pattern, and you wish that you can see deep, right? You can use your bare eye to see the various things that come together to actually make the whole body matter, right? But there is a strong machine called microscope that help us to do that. Now, microscope has revealed a lot of things, and then we realize that when we are looking deep into it, there are a lot of things that we are going to see. All those things that we are seeing, right? We are going to call them, all of them, particles. So when you look into matter, we are going to have particles. Yes. So and there are various form of matter, right? You see, all of them are particles. So we can expect, because they are different matter, there's stable, there is water, there's this. We can expect all of them to have the same particles inside them, right? So all matter that you have, right? Each matter that you have, right? They are made of fundamental components. They are fundamental units that come together to form the whole matter. So this leads us to the concept of basic unit of matter. Yes, so these are the basic units of matter that we have. So when we look deep into every matter, right, we are going to see particles inside them. And these particles that are units, right, they come together to form a particular matter. So all of them are called units, and all of them are called particles, and then they come in different forms. The basic ones that you can see in every matter, you can be sure to see in every matter. You can see the particles as atoms. The particle may come as ions, or they may come as molecules. These are the three basic units of matter. Because whenever you get into a matter at the core level, you should be able to see the particles either as atoms, ions, molecules, or even a combination of them. But then we are sure that these basic things are found in all matter. Okay. They come together to form different things. They form different things. And then when they come together, they give the matter a particular physical form. Right? So those forms, we call them states of matter. Right? So what are these three states of matter, or three common states of matter? We say common because there's another one that is called plasma that people are exploring, right? But then we are going to majorly focus on three major common states of matter. A common one that you can see, we are sure that 100% you can find around you, right? That's what we are going to look at. So the three states of matter. One, yes. So these are the three states of matter that you can find around: solid, liquid, and gas. We say particles come together to give particular matter a particular physical form. Okay, so the forms, we call them states of matter. So the three forms that we have are solid states, liquid states, and then gaseous states. Let's start with the solid state and see how that looks like. Yeah, so this what I have here. I have something simple here, right? We have the solid states. Let's talk about the solid states. So what we have here is the solid. So all these things are the particles, right? The particle. We are going to call them particle. We haven't identified them as atoms, ions, or molecules, right? Let's call all of them inside the matter particles. So these are the particles of a solid form or solid state, all right? Okay, you see that the particle, each ball is a particle. Each one is a particle, one is a particle, one is a unit, one is a unit. They come together to form a particle. More of these, right? A lot of the here we just cut a portion of the thing. Here is at the microscopic level. We are just looking into matter itself, and we just cut this portion and realize that when you take a matter that is having a solid state, the particles are very close. They are very, very close and tightly packed. You see, they are tightly packed. That's one thing. So they are tightly packed. Tightly packed. That's the first thing about them. This is it. And then if you see, you are seeing some as if they are vibrating, right? Those dark thing you are seeing around them. So particles, each particle, right, doesn't want to stay at one place. They always want to move. So there's always motion. Okay, there's always motion, but because they are tightly packed, there's no enough space for them. So that because they are tightly packed, they are closely packed, what will happen is that they will try to move, but then try to move. By the time you move like one moves like this, it come back, moves to the left to come back, because around them there's no enough space for them to breathe or for them to move, right? So they just at the end they just go up and down, up and down, up and down. They'll be moving around and then be vibrating. So they actually vibrate. So they exhibit vibration of motion. So the vibration at a very fast rate, very, very fast rate. They always vibrate and they are very close, so that such that then when you have the matter in your hand itself, right? You have a matter in your hand itself. For example, the mobile phone. The mobile phone is a solid state. In a solid state, we are having it, right? It's not vibrating in my hand, right? It's not vibrating in my hand. This is a solid state. Not vibrating in my hand. It's hard, right? The particles are closely packed, so that's why it look like it's hard. And then the particles inside, if you look at them on level, they want to move, but then they are restricted because around them other particles are also there and closely packed. So they always vibrate, but then you can see and they move very, very fast that at the end to us it's as if nothing is moving. Okay, so that's about the solid state. Now, that's not all. Let's talk about crystalline and amorphous form of solid state. Crystals. So you've heard of crystals before. So now, when these particles come together in a solid state, what happens is that because they are packed, right, you'll be seeing some patterns. So here, let's say this pattern to here, triangle, and then there's another triangle here, there's another triangle here, there's another triangle here, and this one it will continue, but we just cut a portion. Then this one too, this pattern. I'm just drawing this pattern. You can derive any pattern from this, right, and then continuously. So what happened is that this pattern is seen to repeat multiple times over the entire material. So when you take a large portion of the material, you'll be seeing a regular pattern going through it a long time. The pattern is covering a particular long range. Okay, so they come together. When they come together, they form they form patterns inside the system, inside the particle. So when they form that particle, right? When they form that pattern, the pattern doesn't repeat one, two, then it stops. No, the patterns repeat over and over again before it stops somewhere, or sometimes it doesn't even stop, right? There's a long range of particle arrangements of the same things, right? Now, in that state, if you see that long arrangement of the particles inside the material, we call them crystals. So they are solid, right? Solid that have this long range pattern of the same unit, right? We call them crystals. And the reverse of that are the amorphous. So amorphous, let me try to do this, right? Will I have the same form? I'm just deriving this. This is not a real pattern. You see, it's distorted. So I have to be thinking of getting another pattern. To so it's hard, right? These are solid, they are closely packed, but the pattern is not really visible. Let me get this one. See, this one is closed, and these three, the pattern is not like regular, so you have to be formula. So it's amorphous, it's solid, right? They are closely packed, but then it's solid. So there's that. The only issue is that the pattern doesn't repeat over a long range. So at the end of the day, this one we call them amorphous and crystalline. They are all solids, but crystalline they have repeated patterns inside them over a long range. Amorphous solid, they don't have that. Next one, let's go to the liquid state. This is the liquid state, right? For the liquid, the particles that are inside, right? There's at least some breathing room. They have a breathing space around them. Not that far, but they are a bit free to move around. So this is what happens, right? You see them. Particles always want to move. In solid, they are closely packed, so they just vibrate there. But over here, they don't vibrate. What do? They freely move around. But then the kind of movement they do is that one can move and slide over one another. They can move and slide. They can move freely and be sliding. The other person can slide. That's what happens to water. If you pour water on a table, right? You see with the water moving. what happens is that one particle is sliding over the other. When it lands, the next one also slide. So that slide motion makes we see the water to flow. That's it, right? Another thing is that, so these guys, they are loosely packed. Yes, they are loosely packed. And then for water, right? What happened is that there's enough space. There's some space. What happened is that they don't have a fixed shape. They don't have a fixed shape, so they can the liquid state can enter this container, right? It's having this shape. It's taking the shape of the containers in which we pour them. So this particular state, right? Oil, water, when you when you pour them in the container that you are putting them, right, they will just take the shape of that container. See this one too. Conical flask. See the same liquid we are pouring it inside, but it's just taking the shape of. So they don't have a fixed shape, but the volume there, the volume is the same. The volume is the same. The volume is the same, but then when we are changing the distance, the shape is the one that changes, right? Now let's talk about the last state, which is the gaseous state. These guys, the particle spacing is like very far. They are free to move around, like smoke, perfume, and all that flavor, like food flavor, right? There's a lot of space. So see how they are even moving fast here because they have room, like there's a lot of freedom. So they are just moving anywhere randomly. So they exhibit random motion. So these guys exhibit random motion, and then they what again? So no fish shape, right? There's no fish shape, no fish shape because they can occupy any space. They can spread and cover every space, right? They don't have a volume. They don't have a fish volume, so no fish volume, no fish shape. Yeah, they don't have fish shape, right? No fish volume, no fish volume. That's what they do, right? Okay. Now, this is about the gaseous state. So when you have a matter, right, based on the particles arrangement and spacing, you can do this classification. Let's summarize everything. So this table gives you a summary of everything, right? The state is solid, right? You say particle motion, they undergo what? Vibrational motion or oscillation, oscillatory motion. The particle space, what the space between the particles, they are closely packed for solid, right? That's why they are hard, yeah. The shape, right? The definite shape. So it's hard to change their shape. So when you take mobile phone, you put it on the table, you put it on the bed, the same shape of the mobile phone, right? Unlike water, that will flow and change the shape. Then the volume, the same volume. They don't actually get magnified or this in just on themselves. Compressibility, incompressible. You can compress it, madam. See the solid particles. How do you look at it? We say that they are very close already, and they're even looking for room to move. So what happens is that you can compress them further. If you compress them, you are just trying to say they can. You want to make them closer again. But in the solid state, they are already packed. Already packed. So when you are pressing it, they are incompressible, right? That's it. For the liquid, they are free to move, but they do a sliding motion. They slide over. If they are able to slide over each other, that sliding motion, it means that even though they are free to move, right, they are still close to one another. They are close to one another. So the space is not that much. So they are loosely packed. Now the shape, you say it's indefinite shape. There's no definite shape, but it's indefinite shape because when you pour water inside another container, it has a different shape and different one, different like that. Volume, the volume is the same. The volume is the same. The volume is yeah, the volume is the same for the depending on the container, right? It doesn't change its volume. Volume is the same. Incompressible, yes. Even though we say they are free to move, right? There's a particular space, but then it's not enough for us to compress it to be useful for us. We don't compress them to be useful for us. So for us, we also classify them as very incompressible as well. But like solid is more incompressible than the liquid. If you go to the gaseous state, these particles are free to move. They are free to move, and they move randomly. They are, and then because of that random things, or because of they are far apart. So the particles are far apart. The spacing between them is very huge. Right? They are far apart. They can move. So you have to constrain them in a container if you want to keep them around. Right? So that's for gaseous state. And the shape, definitely, right? The shape is indefinite. They don't have a definite shape. These guys they move around anyhow. The volume, indefinite volume, right? The volume, if you leave them, if you remove them from the container, oh, they can spread around, spread in the room. They they don't care. They don't care. Like they just want freedom to move. So that's about the gas. And then the compressibility. Yes, there's enough space among them, so you can put them together and compress them. So they are compressible. They are highly compressible, right? So you can put them together and then just compress them. So that's why when you have a balloon, you like you pump air into it, right? the air goes in. Air is a gas, right? It goes inside and you compress them and tie them. So you can compress them, put the space together. Yeah, that's about that. But hey, we have an assignment for you. So this is the assignment that we want you to do. Yeah, you are asked to be part of a team that will build a system that handles temperature regulation in food containers. If you are to consider the physical state of the device the team intends to build, what will be your suggestion and why? Note, the project is not to build new food containers, but to improve and integrate the system with current one. So the food containers are already there, they are already there. So we are not building a full project, but then they just come to you asking for the physical state, right, of the device, of the system, of the system. If I say device, you might be thinking of one state alone, but of the system that they will need to integrate into the future, into the current one. So more like what physical states of the system will you suggest and why? That's our assignment. We'll explore it in the next session, then we'll continue adding more concept to what we are learning. See you in the next session.